Moving mean smoothing. Going to start with three mean smoothing because it's one of the easier ones. And we're going to take it nice and slowly. So when we say, of course, mean, we mean about taking the average. So you're going to be taking the average a lot. And smoothing is because you want to look for an underlying trend. Now, this kind of data is quarterly data. So it probably lends itself to four mean smoothing because it's quarterly and there's 4 quarters in a year. But we're going to do three because it's easier to start with. All right, it's a good time for colored pens. I'm going to take this nice and slowly because it's the first one. So we start with these three numbers and average them. And if you do that, you get 2,600. So 4,300 plus 2,800 plus 700 divided by 3, 2,600. Hopefully you know how to do that by now. Then we move it. So we forget about the first one. You notice there's no data point here because you can't get the 3. You can't make 3 like that because there's no number here. So you do get a bit of loss with this data. So this is the next group of 3, and you can see it's centered on number 3. And if you average those 3 out, you get roughly 2,067. Gonna do a bit of rounding off. And again, so we take that 3 and we move across one. So now we're doing the average of 3, 4, and 5. And the average of 3, 4, and 5 should get me 2, 6, 6, 7. Again, just nicely rounding these things off. Then we go for another 3, and this one's going to be centered on 5. So it's 4, 5, and 6. And so when you look at that, you should get 3, 3, 6, 7. And you can keep going, just moving that average along, but I'm sure that's going to get a bit repetitive, so I'm going to pause the video and just do it. Okay, so by the magic of my editing, you can see that we've managed to smooth all that data out, take the averages, and you'll notice, of course, that there's no data point here and no data point here. So if you smooth, you lose. So you're always going to lose some data in this situation. But notice that you can directly center each number on these things. And this is an important thing with odd numbers, that you can actually smooth easily in that situation because you don't have to worry about recentering. So that's how you do that. Later on, I'll show you how to do it all on a spreadsheet, the spreadsheet on the calculator. But there's the graph of it, and you can see it is smoother, but we've still got some fluctuations up and down. It's not perfect, but it's not too bad. We can see that these peaks are not as high and these troughs are not as low. Okay, we're going to do exactly the same thing, but with 5 mean smoothing. So we're going to take the first 5 numbers, so that's numbers 1 with 3 at the center, all the way to 5. And so as you see, the first one is the center, which is 3, so we can't have one at 1 or 2. You can't center 5 data points on 1 or 2. So we lose a bit at the beginning. We're losing more because we're using more numbers in the smoothing. And so if you average up those 5 numbers and divide by 5, because that's how you do all this thing, you get 3020. And again, we move to the next 5 numbers. So we start at 2 this time, and then we go all the way to 6. So we've lost number 1, but we've gained number 6, and our number is 2720. And let's try another one. And so if we go from 3 all the way to 5, and then they're going to go all the way to 7 now, haven't we? So that's 2340. I'm just reading this off some calculations I did already. Let me just pause it and add the rest of the data. Okay, so that's all the data filled in. You notice we miss out on this one and this one because you're smoothing and you're using 5 mean smoothing, you're getting more losses. That line is getting shorter and shorter and shorter. But you do get some weird things because this data is really seasonal and quarterly. You can actually see that like we've actually got this anti thing. So like it's highest when there's a trough and lowest when there's a peak. So it's gone anti because it's on a 5 mean smoothing for data that really should be 4 mean smoothed. But try it out, see if you can get those numbers to do these things. It's all done on the calculator video coming later. Okay, so we're going to do two mean smoothing, and we're going to find there's a little bit of a problem because we need to do an extra step called centering, and I'll explain why you need to do centering. So normally you think, okay, two mean smoothing, just like we did before, you take the first two data points and you average them. And if you average those two, you'll get 3,550. But they're averaged on this line here. And if we do the next one, which is going to be these 2 points, then it's going to be centered here, and you'll get 1,750. The point is, the red line is some autumn, and the green line is autumn-winter. Or you can imagine you got 1.5 and then 2.5 on your timecode, which doesn't make any sense whatsoever. And like, what have you lost? Have you lost half a cell here, half a value? I don't think so. So later on, we're going to do some centering. So first of all, got to fill in all those values for the just the two mean, just the averaging, and then we'll do the centering. Okay, so you can see that all the values have now been filled in. But your problem, as I said, is they're not centered on a particular number. We need to make sure they're centered on a number. So if we take the red one and the green one here, if my highlighter pen starts working, we'd have to center them here in the middle there. So that's what we're going to do. And probably put that number back. So if we average these two, they'll be centered on number 2. So if you do that, you will get the value of 2,650. And then you do the same thing with the next one. So you're going to average these two to center now on 3, and you should get 1,725. That makes sense. And so on and so forth. Average those two, that's what we're centering, and now you get 2,675. I'll pause the video and fill in the rest. Okay, so that's the rest of the values filled in, and you'll notice now that we don't have a value for 1 or for 12. So we have lost some data as expected, same amount of data as you lose with 3 mean smoothing, but now we've got the centering. So that second step that we did where we averaged the averages, as it were, is the centering. If we look at our graph, it looks like this. Not the smoothest thing in the world, but there we go. Next, onto the 4 mean smoothing, which should actually give us a great result, hopefully. 4 mean smoothing. Now, because we've got an even number, just like we have with 2 mean smoothing, you've got to do some centering. So 4 mean, so you take the first 4 numbers, and as you can see, that means it's centered here. And if you average those 4 numbers, you will get 2,625. And then we move the mean along 1. So now it's from 2 to 5, and we average those numbers, and you get 2,700, which is centered here. And again, it's centered on the line, so we can't, I mean, the red one is somewhat windsprung, and the green one is alt windsprung some. Not a thing. So what we're going to try and do is just average all those 4 in a moving mean with the paused video. Okay, so by the magic of editing, there we go. There's our values. But again, we can see that we're not on the center of a value. So we're going to take these two and average them out so that we're actually centered on 3. And if you do that, you should get 2,663 with some rounding, of course. Then you do the next one, you should get 2,700. That wasn't hard to do. Don't need a calculator for that, and so on and so on. Let me just pause again. Okay, and now you can see that we do definitely have some loss. So we've got nothing in 1 or 2 or I'm going to get this right. So we've centered at 3, 4, 5, 6, 7, 8, 9, 10. So we've also lost 12, and we're centered on 10 as well. So we lost 2 off the end there. And if you put the graph up like this, can you see, because this is quarterly data, the seasonality was quarterly. When you smooth it, it really does smooth just the way you want it. Lovely flat thing. And what you're doing smoothing for is to reveal an underlying increasing trend. Okay, this is questions 15 and 16 from last year's exam, and it's just asking for the median. And so there's nothing to do with smoothing, but just imagine you have a bunch of numbers. You've got 5, 4, 3, 2, 1. When you're finding the median, you kind of like crossing off pairs, tops and bottoms, and tops and bottoms. So they're in pairs. So we can do the same thing here. Here's a top, there's a bottom, here's the new top. I think that one's the bottom. There's a top and a bottom. That looks like a top and a bottom. And we could probably say, oh, there's a top and there's a bottom. So it's between this one and this one. Now, if you read across horizontally like that, it looks like there, and then that one looks like it's about there. I would suggest it's somewhere close to between 100, and these are obviously going up by tens on the left-hand side. So it looks like that is the best candidate by my reckoning. Okay, so the reason I did this question was because question 16 is about 7 mean smoothing. Now it's not asking you to do any calculation. It wants to know the number of smooth data points you have after you've smoothed it. So you can imagine easily 7 smoothing. So you take the first 7 data points, 1, 2, 3, 4, 5, 6, 7. Now obviously that's going to be centered on the middle one of those 7, which means we lose these 3 data points. And if we repeat the process from the other end, do a different color, 1, 2, 3, 4, 5, 6, 7. Again, you can see that this one, and this one are lost because we're centered on this one. So if you now, you need to look at how many smooth data points you'd have one centered on here, and so 2, 3, 4, 5, 6. Looks like the answer is in fact C.